This is the Unit 8 test study guide for studying right triangles and trigonometry. We'll start with topic number 1, Pythagorean theorem and its applications. For any right triangle, we know that a squared plus b squared equals c squared. That's where a and b are the legs and c is the hypotenuse. Let's look at problem number 1. So problem number 1, we're looking for the hypotenuse here. So we're going to take one side, square it, plus the second side, square it, and that's going to equal the hypotenuse squared. So now if we take this and take the square root of both sides, we're going to get x. If we put this in our calculator, second square root of 9 squared plus 17 squared, we're going to get x is equal to 19.2. On number 2, we're looking for a leg. Remember, the hypotenuse is always across from the right angle. So here we're looking for a leg. So we can say that x squared plus 11 squared is equal to 14 squared, the hypotenuse. So let's move the 11 squared to the other side. So that's going to give us x squared is equal to 14 squared minus 11 squared. We take the square root of both sides. So x then is equal to 8.7. Let's look at number 3. Number 3, again, we're looking for a leg. So we're going to say x squared plus the other leg, 6.8 squared, is equal to the hypotenuse, 8.1 squared. We move the 6.8 squared to the other side. So that gives us x squared is equal to 8.1 squared minus 6.8 squared. We then take the square root of both sides. Put that in our calculator. So x is equal to, put this in our calculator, and we get 4.4. Number 4. Now, number 4 looks like a complicated problem, but if you see, we have two triangles exactly the same. So if we would solve for, we could call it y here, for this triangle, all we did do is double y and we'd have what x is. So let's try that. So here we've got y squared is equal to, now y squared here is a leg, isn't it? So we can say that y squared plus 13 squared is equal to 18 squared, the hypotenuse. Now we can move the 13 squared to the other side. If we do that, we get y squared is equal to 18 squared minus 13 squared. Now we're going to take the square root of both sides. So we see that y is equal to 12.4. Okay, so then x, we said, was going to be equal to 2 of these y's. One here, one here. So x is equal to 2 times 12.4. So x is equal to 24.8. Okay. Let's look at number 5. And number 5 talks about an Olympic swimming pool. It's approximately 50 meters by 25 meters. What distance will a swimmer travel if they swim from one corner to the opposite corner? Okay, so we have a right triangle, and we're looking for the hypotenuse. So we could say that x squared is equal to 25 squared plus 50 squared. Now we can take the square root of both sides. If we do that, then we see that x is equal to 55.9 meters. Very simple problem. Okay, let's look at number 6. Number 6 says a 20-foot ramp is used at the loading dock of a factory. If the base of the ramp is placed 19 feet from the base of the dock. How high is the loading dock? Well, let's see. So we have a 20-foot ramp. That's 20 foot. And it's 19 feet. It's 19 feet from the base of the loading dock. And they want to know how high is the loading dock. So that's our picture. We've drawn it. We've labeled it. So what we're looking for is a leg here. So we could say that x squared, that leg, plus 19 squared, the other leg, is equal to 20 squared, the hypotenuse. So we can move the 19 squared to the other side. So we have x squared is equal to 20 squared minus 19 squared. And we take the square root of both sides. When we do that, put that in our calculator, we find that x is equal to 6.2. Now it's going to be 6.2 feet. Okay, let's move on to topic number 2. Pythagorean theorem, converse, and classifying angles. So given a triangle with side lengths ABC, we know that if c squared is equal to a squared plus b squared, then it forms a right triangle. If c squared is less than a squared plus b squared, then it forms an acute triangle. And if c squared is greater than a squared plus b squared, then it forms an obtuse triangle. But in doing this, we have to remember that in order to be a triangle, the sum of the two smaller sides must be greater than the third largest side. Okay, let's go to page 2. Alright, so we'll try some of this out. So the first thing we want to do on this problem, it wants us to select, is it not a triangle? Is it acute, right, or obtuse? So let's first look. If I add these two together, I get 41. Is 41 greater than 29? The answer is yes. Okay, so it forms a triangle. Now, I'm going to take these two legs and put them in my calculator. So I'm going to say second square root of 20 squared plus 21 squared. And when I do that, I get 29. So if I had a triangle, this is 20, this is 21, I had a triangle, did the Pythagorean theorem, which I did, this is 29. Now, what we have been given here, that's 29. So that tells me that this is a right triangle, a right triangle. Let's look at the next one, number 8. Now, number 8, 5 plus 9 is 14, and 14 is greater than 10. Yes, so it does form a triangle. Now, let's do the Pythagorean theorem on these two legs. So I'm going to say second square root of 5 squared plus 9 squared. And when I do that, I'm going to get 10.3. 10.3. Okay, so if I had a triangle here, and I had the sides were 5 and 9, and I'd have 10.3 to make that a right triangle. But you see, I don't have 10.3, I have 10, so it's not quite that long. Not quite that long. So what happens is, I have less than a 90-degree triangle. Less than 90 degrees would be acute. Acute. Okay. Let's look at number 9. So number 9, if I add 15 plus 3 is 18. Is 18 greater than 18? No. Does not form a triangle. Okay. Now let's look at the next one. On this one, if I add 16 and 21, I get 37. 37 is greater than 28, yes. So let's do the Pythagorean theorem on these two. So I'm going to say second square root of 16 squared plus 21 squared. And that's going to give me 26.4. 26.4. So if I had a right triangle, this was 16, this is 21, it's an exact right triangle, then this hypotenuse would be 26.4. But look what I have. I have 28. So 28 is going to go further, where that's going to make more than a 90-degree angle. More than a 90-degree angle. So that's going to be obtuse. Obtuse. Okay, so those are some good examples of that. Now we'll move to topic 3. Now in topic 3, special right triangles. Now, in working problems that involve special right triangles, we always have to put the template on our triangle. So here we know in a 45, 45, 90, we know these two sides are congruent. So this would be x, this would be x, and this, if you did the Pythagorean theorem on the legs, you get x on the square root of 2. Now, if we're doing the 30, 60, 90 triangle, we know that across from the 30 is x. Across from the 60 is x on the square root of, if you get confused, there's the 3. X on the square root of 3, and this is 2x. That's our template. That's what we're going to use to superimpose to work problems. So let's look at problem number 11. Make this a little larger. Okay, they want us to find x and y. So this is a 45, 45, 90 triangle. So this is x, this is x, and this is x on the square root of 2. So right here, I see that x is equal to 5. Now their x, for the problem, it's the same as our x, so x is 5. Now y was equal to x on the square root of 2. So y is equal to 5 on the square root of 2. And we can leave it in the radical like that. Let's look at number 12. Okay, on number 12, we have a 30, 60, 90 triangle. So across from the 30 is x, across from the 60 is x on the square root of 3, and across from the 90 is 2x. So this tells us right here that x is equal to 9. So x is equal to 9, that's our x. Now, their x right here is 2 times our x. 2 times 9, 18. Okay, now y is equal to x on the square root of 3. So y is equal to, our x was 9. 9 on the square root of 3. Okay? Now, let's look at number 13. So 13 is a 30, 60, 90 triangle. So this would be x. This would be x on the square root of 3. And this would be 2x. So I'm always looking for a number for a match. Here we have 2x is equal to 22. Divide both sides by 2, so x is equal to 11. So our template x is equal to 11. So over here, this x is equal to x on the square root of 3. So x is equal to 11 on the square root of 3. So that's our x. 11 on the square root of 3. Now here, y is equal to the template x. So y is equal to 11. Alright, let's look at number 14. So 14 is a 45, 45, 90 triangle. So this is x, this is x, this is x on the square root of 2. Okay, so here we have a match. So we see that x on the square root of 2 is equal to 16. So we could divide both sides by the square root of 2. If we did that, if we didn't want to work with radicals, say, if we did that, we'd have 16 divided by square root of 2. That would give us 11.3. 11.3. Okay, so our x over here is 11.3, and our y is also 11.3. Now, if you wanted to do this in radicals, you get that x was equal to 16 on the square root of 2. Then you'd have to take this out of the denominator, this radical, so you multiply the numerator and the denominator by the square root of 2. That would give you 16 on the square root of 2 over square root of 2 times square root of 2 is square root of 4, which is 2. So then x would equal, if you did the reduction here, 16 over 2 is 8 on the square root of 2. So that could have also been your answer in radical form. All right, let's look at number 15. Now, number 15, we have a 30, 60, 90 triangle. So this is x. This is x on the square root of 3. And this is 2x. Now, here's a match. X on the square root of 3 is equal to 42. So if we divide this by the square root of 3, divide this by the square root of 3. So x then would equal, let's put that in our calculator, 42 divided by square root of 3. So if we do that, we get 24.2. Okay, so that's 24.2. Now, so the template x and their x is the same, so this is 24.2. Now y is equal to 2x. So y is equal to 2 times 24.2, which is 48.5. So this is 48.5. Okay, number 16. Let's look at 16. So 16 is 45, 45, 90 triangle. We know this is x, this is x, this is x on the square root of 2. So here we have a match right here. So x on the square root of 2 is equal to 19 on the square root of 2. The square root of 2's cancel each other. So x then is equal to 19. Okay, so here our x and their x are the same, so this is 19. Y is also 19. All right. Now we move into trigonometry. So in trigonometry, the thing we want to remember is, how do we remember which sine, what's the sine, what's the cosine, what's the tangent? To do that, we use SOHCAHTOA. SOHCAHTOA. So we all know that the sine is equal to the opposite over the hypotenuse. The cosine is equal to the adjacent over the hypotenuse. The tangent is equal to the opposite over the adjacent. The tangent is the one that doesn't have hypotenuse in it. Okay, so let's look at a problem. For each trigonometric ratio, give your answer as a fraction in the simplest form. So it wants sine q. Okay, so let's back up a minute. They want the fraction in the simplest form. Okay, so let's reduce this. If I reduce this, I can divide 2 into each of these. I'd get 8 over 15. Okay, now I need to know what this third side is. So if I do the Pythagorean theorem on this, I'm going to get 17 for the hypotenuse, 17. Okay, now I'm ready to go. So the sine of q, so here's q, here's the angle. I put my eye and I look across. The sine is the opposite, which is 15, over the hypotenuse, 17. The cosine of q, so the cosine would be the angle adjacent over the hypotenuse, 8 over 17. The tangent is the opposite over the adjacent. The opposite, which is 15 over the adjacent 8. 15 over 8. Okay. Now, the sine of r. So here's our reference angle r. Sine would be the opposite over the hypotenuse. 8 over 17. Cosine would be the adjacent over the hypotenuse. 15 over 17. The tangent would be the opposite over the adjacent, 8 over 15. Okay? Now, let's work some problems. So here it says solve to the nearest tenth. So here's my reference angle. So if I look over here, this is the opposite over the adjacent. So that's tangent. So the tangent of 54 degrees is equal to the opposite, which is x, over the adjacent, which is 9. Multiply this times 9, multiply this times 9. So x then, so I put it in my calculator. 9, hit the tangent button, 54 degrees, hit enter. Now, I get 12.4. 12.4. Now, one thing to remember, you may get a negative number when you do this. So what you have to do is you have to go to your calculator, and you have to go to mode in your calculator, to the mode button, and you've got to check and make sure that you're on degree. The fourth one down is radian or degree. You have to select, if you're not on degree, select degree and hit enter so that you will get the right answers when you do trigonometry. Now, let's go to number 19. So 19, so 19, okay, so we have a 46-degree angle here. So this would be the opposite over the hypotenuse. Opposite over hypotenuse, that's the sine. So we'd say the sine of 46 degrees is equal to the opposite 24 over the hypotenuse x. So now, to solve, we're going to multiply this side times x and this side times x. Gets rid of the x's. Now, so we have x sine 46 degrees is equal to 24. So now we're going to solve for x, so we're going to divide this by sine of 46 degrees, divide this by sine 46 degrees. And when we do that, we see that x is equal to, let's put in our calculator, 24 divided by the sine of 46 degrees. When I do that, I get 33.4. 33.4. Okay? Let's look at number 20. Here's number 20. Here's our reference angle across. So that's the opposite over the adjacent. So that would be the tangent. So the tangent of 27 degrees is equal to the opposite over the adjacent. 13 over x. So multiply this side times x, multiply this side times x. Okay, so now we have x tangent, 27 degrees is equal to 13. Now we're going to divide this side by the tangent, 27 degrees. We're going to divide this side by the tangent, 27 degrees. That cancels that out, so x is equal to, I put in my calculator, 13 divided by, hit the tangent button, 27 degrees. And that's going to give me 25.5. 25.5. Okay, let's look at 21. So 21, so here, now here, so this is the opposite, this is the adjacent over the hypotenuse. That's the cosine. So the cosine of 35 degrees is equal to the adjacent over the hypotenuse. Now, so I'm going to multiply both sides by 21 to get this out of the denominator. So I see that x is equal to 21 cosine of 35 degrees. When I do that, I get 17.2. 17.2. Let's look at 22. So here in 22, now this is different now. They want us to find x, the angle. They want us to find the angle. So a little bit different. So let's see how we do this. So this is the opposite over the hypotenuse. So that's the sine. So I'm going to say the sine of x is equal to the opposite over the hypotenuse. Now, once I set this up, then I say x is equal to the inverse sign. The inverse sign of this ratio, 23 over 24. So then x is equal to, now I'm going to go to my calculator and I'm going to press second sign, the second button, and then sign, and then I'm going to put in the fraction 23 divided by 24 and hit enter. And when I do that, I'm going to get 73.4 degrees. That's the measure of this angle. Okay, so remember how we do this. We set up the equation. We immediately then, when we're looking for the angle, we go to the inverse of the function. Second, in this case, second sign. All right, let's look at another one. Let's look at 23. So 23, looking for this angle. So this is the opposite over the adjacent. Opposite over the adjacent. So that's the tangent. So the tangent of x degrees is equal to the opposite, which is 10, over the adjacent, which is 13. Okay, so now we're going to say x is equal to the inverse tangent of 10 divided by 13. So if I put that in my calculator, I'm going to say second tangent of 10 divided by 13. If I do that, I get 37.6. X is equal to 37.6 degrees. All right, let's look at number 24. So 24, here's my reference angle. That would be the opposite over the hypotenuse. Opposite over the hypotenuse. So that's the sine. So the sine of x degrees is equal to the opposite over the hypotenuse. Okay, so then I can say the x is equal to the inverse sine of 30 divided by 39. So if I put that in my calculator, I'm going to say second sine of 30 divided by 39, and that's going to give me 50.3. So x is equal to 50.3 degrees. 50.3 degrees. All right, so let's look at number 25. So here's the angle. So I have that's opposite, that's adjacent over the hypotenuse. That's cosine. The cosine. So the cosine of x degrees is equal to the adjacent, which is 17, over the hypotenuse, which is 18. So then I say that x is equal to the inverse cosine of 17 divided by 18. So if we put that in our calculator, we're going to say second cosine of 17 divided by 18, and that's going to give us 19.2. So x is equal to 19.2 degrees. Okay, that's some good examples. Hopefully that's clear. Okay, last page, we have some word problems. So let's look at the applications. Use a picture to solve the problem. We always want to draw a sketch and label it. So a town, let's see, a town does an outdoor movie night every Saturday during the summer on a large screen. Katie is sitting 36 feet from the base of the screen watching the movie with her family. If the angle of elevation from Kate to the top of the screen is 24 degrees, how tall is the movie screen? Okay, so we have something like this. So Kate's sitting here. There's the top of the movie screen. This is 24 degrees. She's 36 feet from it. And they want to know how tall is the screen. So we use trigonometry for this. So this would be, for our reference angle, the opposite over the adjacent. So that's the tangent. So we'd say the tangent of 24 degrees is equal to the opposite over the adjacent. Now, to solve, we'd multiply this times 36, this times 36. So we'd see that x is going to equal 36 times the tangent of 24 degrees. And that's going to give us 16 feet. 16 feet. Okay? Let's look at the next one. Elijah is looking up to the top of the Washington Monument. If the monument is 555 feet tall, so let's see. We've got the Washington Monument up here. It's 555 feet tall. He's looking up, and the angle of elevation from the point on the ground where Elijah is standing is 74 degrees. So this is angle of elevation 74 degrees. How far is he standing from the base of the monument? Okay, so that's x. So if we look at this, we have the opposite over the adjacent. So that's tangent. So we'd say the tangent of 74 degrees is equal to the opposite over the adjacent. So we multiply both sides by x. Get rid of that. So we'd have x tangent 74 degrees is equal to 555. Now we divide both sides by the tangent 74 degrees. And so we find that x is equal to, so let's see what we have, 555 divided by the tangent of 74 degrees. And that gives me 159.1 feet. Okay. Let's look at the next one. While parasailing, Ryan spots over, he's on a parasail here. So he spots out here, he spots a dolphin in the water below. If Ryan is 228 feet above the water, so this distance is 228 feet above the water, and the angle of depression is 15 degrees. So he spots this dolphin out here. His angle of depression is 15 degrees. What is the horizontal distance between Ryan and the dolphin? So what is this distance? Now, so this imaginary line is parallel to this line. Parallel. So alternate interior angles, this would be 15 degrees. This is 90. So now we could say we're looking at the opposite over the adjacent. So that would be the tangent. The tangent. So the tangent of 15 degrees is equal to the opposite over the adjacent. Okay. So now we're going to multiply this times x, this times x. So that's going to give us x tangent 15 degrees is equal to 228. Divide both sides by the tangent 15 degrees. So if we do that, we have x is equal to 228 divided by the tangent of 15 degrees, 850.9. So it's 850.9 feet. Okay, let's look at the next one, number 29. So number 29, it says that the angle of depression from an airplane to the top of the air traffic control tower is 56 degrees. If the tower is 320 feet tall and the airplane is flying at an altitude of 7,450 feet, how far away is the airplane from the control tower? So let's say that this is a ground level. This is our control tower here. Our control tower is here. It's 320 feet tall. 320 feet tall. Then we have an aircraft out here. An aircraft is flying. The angle of depression, so the aircraft to here, So the angle of depression, is 56 degrees. It said flying at an altitude of 7,450 feet. How far away is the airplane? Okay, so the first thing we have to do is we're going to have to make a right triangle here. So we have to know, what is this distance? So this distance is going to be 7,450 minus 320. 7,450 minus 320. And I get 7,130 feet. That's this distance. Okay, now, alternate interior angles, this is 56 degrees. So I have the opposite over the hypotenuse. That's the sine. So I'd say that the sine of 56 degrees is equal to the opposite, 7,130, divided by, we're looking for this, aren't we? Okay, so that's not correct. So this is the opposite over the adjacent. Opposite over the adjacent. So that's the tangent. The tangent of 56 degrees is equal to 7,130 over x. Okay? So now we're going to solve, so we multiply this times x, multiply this times x. So that tells us x tangent of 56 degrees is equal to 7,130. Now we're going to divide both sides by the tangent of 56 degrees. Okay, if we do that, we have x is equal to, so we have 7,130 degrees divided by the tangent of 56 degrees. So that's going to give us 4,809.2 feet. So that's how far the aircraft is away from the control tower. Okay, let's look at the last one here. It says find the angle of depression from the top of a lighthouse 275 feet above the water to a boat 1,324 feet offshore. So if we have a tower here. Okay. Now the boat is 1,300. Here's the boat. So the boat is 1,324 feet offshore. So this is 1,324 feet offshore. Okay. Now here's the lighthouse. Here's the lighthouse. Now they want to know the angle of depression. So that's parallel to that. So they want to know this, which is the same as this. Now, what do they want to know? Find the angle of depression. This is 275 feet tall. Okay, so this is going to be the opposite over the adjacent. So we're going to say the tangent of x is equal to the opposite over the adjacent. Okay, so we're looking for the angle. So we're going to immediately say that x is equal to the inverse tangent of this ratio, 275 over 1,324. Now we're going to put that in our calculator. So we're going to say that we have second tangent of 275 divided by 1,324. Now when we do that, we get 11.7 degrees. 11.7 degrees. Okay. So that finishes up the Unit 8 test study guide.